So here is the review video of the Test 1 Semester 2 review sheet. So the idea is to watch the video, look at the review sheets, and then do the corrections for the test, whether it be just the specific standards you need or the whole thing, whatever you can do to try and pass the class. That's what we want you to do. So do the corrections, somehow submit it to me, take a picture, whatever it is, and then I'll find a time or find a way to get you the retest. Take the retest, work on passing the class. So here is the review video for the first unit in semester 2. All right, number 1, we want to find the sine, cosine, actually the 6 trig functions for this triangle. Okay, all we want to do is write down the fractions. So sine is going to be opposite over hypotenuse, and our angle is at Q. Oops. Angle is at Q, so the opposite is going to be 5. The hypotenuse is 13. Cosine, adjacent over hypotenuse, so 12 over 13. Tangent is opposite over adjacent, so it's going to be 5 over 12. Okay. Excuse me. For the other 3 trig functions, you're just going to do the reciprocals. So cosecant is 13 over 5. Secant is 13 over 12. And cotangent is 12 over 5. Okay. For number 2, find the 6 trig ratio. So what you have to do in this case first is before you can start writing the ratios down, you have to find out what this side is, the hypotenuse side is. We don't know, but you can figure it out using the Pythagorean theorem. So if you do 5 squared plus 8 squared, you're going to get 89. But it's going to be the square root of 89. So the hypotenuse is the square root of 89. So now that's our hypotenuse. If theta is our angle, we're going to write down the fractions. So the first one is 5 over the square root of 89. But you can't leave square roots in the bottom of your fractions, so you have to multiply it to the top, which gives you 5 square root of 89 over just 89. For cosine, the opposite is 8 divided by the square root of 89. Again, you're not allowed to leave square roots on the bottom of your fraction, so you multiply it to the top. So you're going to have 8 square root of 89 over 89. And then finally, for tangent, you have opposite over adjacent, you have 5 over 8. For the reciprocals, it's actually easy to do the reciprocal because the reciprocal of sine, the original sine, is just the square root of 89 over 5. Same thing with secant, the square root of 89 over 8. And cotangent is just 8 over 5. Okay. A lot of times people want to do decimals for these. You're not supposed to do decimals. You're supposed to do the exact. So you do the square roots. Next. For these problems, you got to do 2 things basically, which is set up the problem and then solve it. So to find the measure of each angle. So for this one, for number 3a, you can use anything you want. I'm just going to use sine. So the sine of theta is going to equal 7 over 25. So to figure this out, 1, you got to make sure your calculator is in degrees. If you don't have a calculator, you do. It's on your iPad. Go to the self-service app, type in Calculate 84 and download that app, and you can do all these problems in that calculator. So you do the inverse sine. So it looks like this of 7 over 25, and that gives you theta is 16.26. Okay. The only things I really need to see are the setup and the answer. I don't need to see the work in between. All right, next. One of the problems people have with these types of questions, they're not sure which function to use. The problem tells you which function to use. So we have theta here. We have the opposite over the hypotenuse. That is the sine function. So the sine of theta is equal to 11 over 20. The inverse sine of 11 over 20, theta will be 33.37. All right, number 4. Now we're trying to find sides. Again, the equation will tell you which function to use. You have the opposite and you have the hypotenuse. So you're going to use the sine of the angle equals opposite over the hypotenuse. So you're going to multiply by C and then divide 5 by sine of 33. C will equal 9.18. All right, for number 5, okay, so we're going to use the opposite on the adjacent, so it's going to be tangent of 25 degrees is equal to the opposite. Oops, let's make sure that looks like an A and not a 9 over 19. So you multiply by 19 on both sides, and A will be 8.86. For 6A and B, these are 45, 45, and 30, 60, 90 triangles. Okay, so the relationship is, for 45s, this is x, and this is x, and this is x root 2. So we're going to find out y is, if x is 14, put 14 in for the x, and this would be 14 root 2. For b, all right, this is the 30 degrees. That means this side is x, this side is x root 2, or sorry, x root 3, my apologies. And then the hypotenuse is 2 times x. Okay, so if the 60 degree side is x root 3, x is 6. So we'd multiply 6 times 2, we're going to get 12. All right, finding the areas for these following triangles. Okay, you are given 2 formulas at the very top. So let's roll back up to the top. Here's the first one. I'll highlight it. 1/2 times AB times the sine of C. So if you're given 2 sides and an angle, you're going to use this formula, which is what we have here. So 1/2 times A times B times the sine of 44. Okay. So if you plug that into your calculator, the area of the triangle is 13.89. Okay, for the other type of triangle, let's go back up to the top. You're given 3 sides. There's 2 formulas for it. First, you have to find what S is. Use this formula. And then once you find S, you're going to use the second part of the formula. So that's right here. Okay, 2 separate things. So we go back down to our problem. To find S, you take 7 plus 15 plus 10, add them all up. Once you add them all up, you're going to get 32. Divide it by 2, and S will equal 16. Now that we have S in there, we're going to put that into the other formula. I'm going to kind of make it shorter because it's not necessary to be so big. A is going to equal the square root of S, which is 16, times S minus 10, which is 6, times S minus 15, which is 1, times S minus 7, which is going to be 9. You plug that in your calculator, and the area will be 29.39. Okay, for 8, you want to draw a picture for these. It makes it a whole lot easier to do these. So a slide is 3.9 meters long. So here's our slide. And that is 3.9 meters long. The slide makes a 35-degree angle with the ground, so there's the ground and the slide together. That's 35 degrees. How many meters is the top of the slide above the ground? So if the top of the slide is up here, the ground is down here, we want to know this value. So that's the opposite of the hypotenuse, so we use the sine of 35 is equal to the opposite of the hypotenuse. Multiply both sides by 3.9, and the top of the slide is 2.24 meters above the ground. Number 9, angle of elevation for a point on the street. So here's a point on the street to the top of a lamppost. So here's our lamppost. It is 22 degrees. Okay, the lamppost is 8 feet tall. We want to know how far is the point on the street to the base of the lamppost. So the point on the street to the base of the lamppost is the x value. So we're going to use the tangent because we're given the opposite and we want to find the adjacent. So the tangent of 22 is equal to the opposite over the adjacent. So you multiply both sides by x and then divide 8 by tangent of 22. So x will equal 19.8. All right. For these problems, this is the law of sines and cosines. Again, those formulas are given to you at the top. Some easy ways to figure out what these are is if you have a pair, you're going to use the law of sines. If you don't have a pair of an angle and a corresponding side, then you use the law of cosines. So in question number 10 here, we have angle C, side A, and side B. There's no pair. So we're going to use the law of cosines. So all you have to do is fill in the values into the formula. So we have C squared is equal to 6.5 squared plus 9 squared minus 2 times 6.5 times 9 times the cosine of 52.5. Now the nice thing about this particular problem is you can put this all in your calculator all at once, so put it all in at the same time. Don't do it in pieces. Do 6.5 squared plus 9 squared minus 2 times 6.5 times 9 times the cosine of 52.5 and hit equals. Then take the square root of everything because this is x or c squared and c will equal 7.21. Okay, I told you guys at the beginning when we did these problems I needed two things. I need the setup of the problem, the rest is a calculator question, and I need the answer. So that's what I need right there. For question number 11, we have A, we have B, and we have B. So now we have a pair of a side and an angle. So we can use the law of sines. So we have the sine of 105 over A equals the sine of 27 over 10. Okay, we cross multiply and we solve, and A is going to equal 21, oops, 0.28. Okay, now if we're thinking about a second triangle, that wouldn't work for this one because if you subtract 180 from 21.28, actually I lied, hold on, I lied all in general. We don't need that because we're not trying to find another angle. This is a side. So my apologies. Don't even worry about a second triangle because that's only when we're trying to find an angle using law of sines, not trying to find a side. Okay, so moving on. Number 12. We have side A, side B, and angle A. So again, because we have a pairing, we have A and A, we're going to use law of sines. So we have the sine of 50.7 over 10.1 equals the sine of B over 18.2. Now, if you do the calculations for this, you're going to find out that you're going to get an error message when you do the calculations. You're going to get no triangle. It doesn't work. Okay, and then 13, we have side A, side B, and angle A. So again, we have a pairing of both A's. So we're going to do the sine of 35 over 7.5 equals the sine of B over 12. So you're going to find out that B is going to equal 66.6. Now in this case, because we were finding the angles, we do have to check for a second triangle. So to do this, you take 180 minus 66.6. That gives you a second angle of 113.4. Now we have to check this to make sure it works. So we take the 113.4 plus 35 from the other angle that we know of in the triangle. And that is less than 180, so that will work. It leaves you enough room to have a third angle. So these are the two angles you're going to have. Okay, so anytime you have a law of sines problem and you're trying to find the angle, you check for the second angle just to see if it does or does not work. Sometimes it won't, sometimes it will. Okay, now we're on to the word problems here. All right, so to approximate the length of a lake, we have a little triangle here. Okay, now one thing about this is if this whole thing is 110 here, That means inside along the straight line, this is 70. Okay? So the 110 is now inconsequential. We don't need it anymore. We want to find this x value at the bottom here. And since we don't have a pairing, we don't have a side on its corresponding angle, we're going to use the law of sines. Or sorry, law of cosines. Law of cosines. So we have x squared equals 270 squared plus 245 squared minus 2 times 270 times 245 times the cosine of 70. Okay, so again, you can put that all in your calculator at once, get that answer, and then square root it because it is x squared. So x will equal 296.1. All right. Next question, we got a tree question. Okay, so we want to find the x value at the bottom here. Okay, so we have a 5-foot strap. That's the connecting the tree to the ground. That's given to you. All right, it says there's a 25-degree angle between the tree and the strap. So here's the tree, here's the strap. This is 25 degrees. Let's make that a little bit clearer. This is 25. All right, so what you can see here is we have a pairing. We have 5 and 108. That's a pairing of a side and its corresponding angle. So we can use law of sines. So we have the sine of 108 divided by 5, and that equals the sine of 25 divided by x. Okay, so you cross multiply, solve for x, and that will equal 2.22. Okay. Finally, 16. 16 has 2 pieces to it. Okay, it says you observe 2 hot air balloons at equal altitudes. The first balloon is 12 miles from the airport, and the second balloon is 17 miles from the airport. That gives us that. The observed angle between them is 70 degrees, so that's all given to us. So it wants to know how far apart are the balloons, so we're going to find this distance as an x, and then for part B, it says what angle will the first balloon make with a straight line to the airport and the straight line to the second balloon. So here's balloon 1. We want to find out what is this angle. Excuse me. All right, so first thing is we have 2 sides and an angle, and there's no pairing. So we're going to use the law of cosines for part, for part A. So we have x squared is equal to 12 squared plus 17 squared minus 2 times 12 times 17 times the cosine of 70. Again, put that all in your calculator, and once you get your answer, take the square root of both sides, and x will equal 17.13. So, we have that now. Oops. Let's try that. There we go. 17.13. So what we're going to do now is we're going to use this value in our next problem for B, okay, to find what the y value is, this angle. Okay, so now we have a pairing. We have 17.13 and 70 as our pairing. So we can do the sine of 70 divided by 17.13, and that's equaling the sine of y, and then the corresponding side to angle y is 17. Okay, so now if you do cross multiply, do the inverse, and y will equal 68.84. There's your answer. All right, so I know I went through this a little bit quickly, and I just showed you the setup and not necessarily how to solve the problem, but again, I told you at the beginning when we started this unit, I need the setup, and the rest of it you can do in the calculator. You don't actually have to write anything else down. I don't need to see it. I'm grading these 2 things. 1, can you set up the problem correctly? And then 2, can you find the answer using your calculator? All right, so again, please go through this. If you're having problems, let me know. Do the corrections for this first unit test, and then I will schedule the time for you to do the retest, and then hopefully